Hey everyone, welcome to today's video. So today we're going to have a quick video on how to set up Kubernetes using Kubeadm. There's lots of different ways that you can get a Kubernetes cluster up and running. One of the quickest methods is using K3s. But if you're interested in getting certified as a Kubernetes administrator or taking any of the security tests, you'll need to make sure that you're using a Kubernetes cluster that's set up using Kubeadm. So for today, we'll go ahead and use that as our method of installation. So in order to get up and running, it's quite straightforward. I've actually created a documentation that we can follow along. There are some prerequisites. So you will need a minimum of 2 virtual machines. In our case today, we'll have 3 virtual machines. I'm going to be installing this on Debian 12, but this should also work on Ubuntu 22 or greater as well. We also need to make sure that we have some minimum specifications for the nodes. I do recommend 2 CPUs and 2 gigabytes of RAM. And then for the worker nodes, you can get away with a little bit less, so maybe 1 CPU and 2 gig. Again, if you can spare a little bit more, it's always recommended. We also need to make sure that we have 2 different network ranges. So we need a static range for the host IP address of the virtual machines, and then we'll need a different range that we'll be using for the pod networking range, and we want to make sure that they do not conflict or overlap. So in our case today, we're actually going to be using the Calico network plugin to set up the pod network. Okay, so without further ado, let's go ahead and I'll just show you here. I have the 3 virtual machines that have been booted. You can see here I have one that's going to be our control plane. We have one that's going to be our first node and second node. Now, if you follow along with the instructions, it's quite straightforward. So the first thing that we need to do is we need to set up the nodes. And some of these need to be executed on all of the machines. So here, the first thing that we need to do is we need to enable IP tables in bridged traffic on all the nodes. So we can simply go ahead and do that by copying this command here, and then we'll paste it into each one of these nodes. And it looks like I was signed out here, so let me go ahead and quickly jump back in again. And we'll do the same here. And then we'll do the same here as well. Okay, so now that we have that, we can go ahead and copy this into each of our nodes. Okay, and the next thing you need to do is we just need to ensure that they get enabled. So we can do that by using the mount_probe command. So let's copy that and execute that on all 3 of our machines as well. Okay, and I'm going to keep clearing the screen just so you guys can follow along. So the next thing that you need to do is there are some sysctl parameters that are required, and we need to make sure that they persist across all the reboots. So we need to enable the following. So let's go ahead and copy these. We'll paste these on all 3 machines as well. And in order to apply those parameters without rebooting, we can just simply do a sudo sysctl -- system. So let's go ahead and do that. Oops, and I missed the copy. Perfect. So now that we have that completed, the next thing that we need to do is we need to make sure that we disable swap on all of the nodes. So in order for Kubeadm to work properly, we need to make sure that this is taken care of. So please make sure that you do disable swap on all of your virtual machines. So let's go ahead and do that. So this will essentially just turn off swap, and then we're going to make an edit in the FS tab to make sure that it persists across all the reboots. So let's copy this. And there we go. We've now disabled swap. So the next thing that we need to do is we need to install the CRI-O runtime on all of the nodes. And again, we'll do this by simply using CRI-O instead of Docker or CRI-O, since that Kubernetes has deprecated the Docker engine. So the first thing that we need to do is create a CRI-O.conf. So let's go ahead and do that. Oops. Okay, so now that we have that, we need to make sure that we also set up some additional syscontrol parameters. So let's copy these. And then just like we did before, we need to use modprobe to make sure that those are loaded. So let's go ahead and do that. Perfect. So the next thing that we need to do is set up a Kubernetes CRI.conf. So let's go ahead and copy this here. And then just like before, we're going to use a system here. Perfect. So we're getting close to being set up with all our prerequisites. So the next thing that we need to do is we need to set up some of the repositories. At the time of recording for this video, the latest version of Kubernetes is 1.28. And here you can see I'm actually setting two environment variables. One which is the OS. In my case, I'm using Debian 12, and the version which is 1.28. I'll also leave a description in the video link below, which will show you how to change this. But essentially, you can just go to this URL here, and you can select the version of the operating system as well as the version of Kubernetes that you want to install. But in our case, we're just going to stick with Debian 12. So let's copy that, and then let's set these on all of the machines. And the next thing that we need to do is we need to add our repositories. So let's copy this and configure our repositories on all of the machines. And then we need to set our repositories for our kubic as well. So let's copy this and get these set up. Perfect. So we need to also make sure that the GPG keys are loaded. So let's copy this and do the same here. Perfect. And then we need to do the same for the other one as well. Great. So let's clear the screen here so we can have some more real estate. So let's go ahead and run a apt update, and then we'll install the CRI-O, the runc, as well as the tools. So let's go ahead and do this. Whoops, I keep moving to the wrong screen here. Okay, so let's do that, and we'll do it on all three at the same time. And this should just take a few seconds, and you can see it's completed here. It should complete on our other two nodes, and there we go. Perfect. So now that that's done, let's go ahead and reload the daemon, and then let's enable. So let's do that. Perfect. So finally, what we need to do is we need to install Kubeadm, kubelet, and kubectl on all the nodes. So I've got the commands listed here, as you can see. You can also visit the official Kubernetes page if you want to install this for your operating system if it's different than either Ubuntu or Debian. So let's go ahead and copy this and get those three installed. And in this case, we just need to overwrite the ring file, which is fine. And we can do that. And we can check that that was installed by doing a kubectl version. Oh, looks like it didn't install, so that's good. So we actually need to make sure that we didn't actually do that. We didn't add the right keys. So let's go ahead and get that sorted out. And then now we need to install it. So this time we should be able to run a kubectl version. So let's hit the up arrow, and there we go. We can see that it is running. The client version is 128.3. Perfect. Okay, so that is everything that we need to do on the kubectl setup side of things. We can also hold the specific versions to prevent upgrades from taking place. So it's a good idea to do that. So why don't we just go ahead and do that? Perfect. Okay, so the next thing that we need to do is we need to set the IP address of each of our nodes. So when we initialize Kubeadm and join our worker nodes, it knows exactly where to communicate to. So in this case, it will need JQ. I've just got a little script here that'll go through and identify the IP address. In my case, the network interface is on ENS 192. Be sure to change this to whatever your Ethernet adapter is. Maybe it's ETH, or it could be something different. But since I'm set up on VMware, it defaults to ENS. So let's go ahead and copy this, and then we'll set this on all three machines, and we need it to be root. So let's make sure we become root here and run that again. We'll become root on this machine. Set that here. We'll become root here as well. Perfect. So let's make sure that that was actually set correctly. So if we echo the local underscore IP, you can see for this control plane it's on 125, and let's just verify that it is set correctly for the other machines, 26 and 27, so we can see that that is indeed now correct. Okay, so the next thing that we need to do is just set some more environment variables. So we need to export the, and again, this only needs to happen on the master node. So we want to set up the control plane. So we want to set the IP address, the node name. In this case, we're just going to use the host name. And then, as we mentioned earlier, this will be the pod CIDR range. So be sure to change your IP address here. I'm using the control plane IP of my machine, which is 1.25. So let's copy that and paste that here. The next thing you need to do is we just need to initialize the control plane or the master node. And you can go through and see that we're using the environment variables that we set earlier. So let's copy that. And then we're going to go ahead and get this installed. So this will take just a few minutes, but once it's successfully initialized, we'll get an output. It'll tell us where the kubeconfig file is located. It'll also paste a join command, which will contain a token, which we can then use to paste on our two worker nodes to have it join into our control plane. So we'll go ahead and do that here in a second. So let's just make sure this finishes. And I'm going to actually let this continue to record because I want you to see how long it takes, but please feel free to skip ahead until this is done, but it should really only take a few moments. And there you go. In fact, you can see that it was actually done very quickly. So now let's go ahead, and what we want to do is we're going to set up our kubectl to be able to talk to this cluster. And in order to do that, we want to copy over the kubeconfig. So let's copy this command, and you can see that that's actually set up here as well. So we're going to copy this. So now if we do a kubectl get nodes, you can see that this is now up and ready. So if we look back at the documentation, we can also look at all the pods to make sure that all the kube systems are up and running. Then you can see that everything is now in a running state. Okay, so the next thing that we need to do is we need to install the Calico network plugin. So this will allow network communication between the cluster itself. We're going to apply this directly from Project Calico. So at the time of recording, the version is 3.25.1, but if you visit their GitHub page, you may be able to apply a newer version. So let's go ahead and copy that. And we can see that that's now been applied. So what we'll do is we'll just watch all the pods on the cluster. So let's do a watch kubectl get pods -a, and we'll wait for the Calico nodes to complete initializing. And you can see that we're almost up and running here. And perfect. So now we can see that everything is in running state. So if we head back to our documentation, you notice that earlier it did put display out onto the screen the join command, but since we installed our Calico network plugin, that fell off the edge of the screen. So in order to re-see that join command again, you can simply type Kubeadm token create and then print the join command. So let's go ahead and do that. Perfect. So this is what we need to execute on both of our worker nodes. And we should do this one at a time just to make sure that there's no race errors. So let's go ahead and copy this. And what we're going to do is we're going to keep that in our buffer. And then we're going to go ahead this time and just do a watch on kubectl get nodes. So we can see right now we only have the one control node. So let's copy this onto our first worker node. This will now use that token to connect in to our control plane, and we can see that it has done so very quickly. And we can now do that on our second node as well. And there we go. We can now see that we have a 3-node Kubernetes cluster that was set up using Kubeadm. We've got one control plane, and we've got 2 worker nodes. And we can see here, if you follow along the documentation. Now, there is an optional step if you want to enable the metrics server in order for us to see the CPU and memory stats. So in order to do that, we need to just modify the configuration file slightly because we do not have a signed certificate. So in order to do that, what we need to first do is download the YAML file for the metric server. So let's copy that. We can head back over to our control plane and let's fetch that. And then the next thing that we need to do is we need to edit the components file. And you'll see here we're going to need to add this line, which basically tells us to allow TLS to be insecure. So the easiest thing that I found is just to search for something that's around this, or in this case, let's do a search within that file for cert-dir. And you can see here that we've found that. And then what we want to do is we want to add this line directly below, and then save and write that file. And then now we can just simply apply that components file. And if we do a kubectl get pods, we'll see that that metric server is being pulled and is getting set up. So let's give that a few moments, and that should be up and running here. Should only take a moment or two. And then what this will allow us to do is it'll allow us to use things like kubectl top pods, top nodes, and there we go. We can see that the metric server has now started. And then let's go ahead and just do a kubectl top node to make sure that everything is working as expected. Perfect. So now we can get the metrics for each one of our nodes, and we can do the same for our pods as well. So if we do a top pods, in this case, there's nothing to deploy, but if we do it across all pods, we can see that. Okay, perfect. So that's going to conclude today's video. In future videos, we'll go through and use this Kubernetes cluster to dive a little bit deeper into some of the questions that are asked on the CKA exam. So it's important that you have a Kubernetes cluster set up using etcd because there are some questions in the exam that will require you to do some troubleshooting involving a cluster that's set up with Kubeadm. Okay, if you liked this video, please consider giving the channel a subscription and a like. If you have any questions, please leave a comment below. Thank you.